Hi everyone. I will show you how to do a truss analysis with SolidWorks. Okay, so that's kind of the final thing that you will get, but I will go back from the beginning. Okay, let me close this one and go back from the beginning. So first, you will create a new part. So File, New, and a part. Okay. Let's save it right now. So File, Save As. Oops. And I will try it. I will call that Truss Demo. Call it the way you want. Okay, I like to begin to save my part. Okay, so I don't know why you keep saying. Here we go. I will in the sketch. I will do a sketch first. So I click on Sketch, make a sketch, and that's important that we have the same plane. So I will do the sketch in the front plane. Okay. I will begin by the outside of the truss. So make sure that you are aligned with the center. Up. I will go on top and this escape. Okay, so you see there's two things that we need to check. We need to check the units. So go back on the bottom right on your units there. And I will use meter, kilograms, and second. Usually we use millimeter or inches, but it's a truss is big, so I will use meter. Here we go. And before I apply the dimensions, I will use some equations. So you go on Tools, Equation, and I will create a length. And let's say I put it 10 meter. So it will be in the units that you have selected, length and height. Let's say I put 3. Oops. It's easy after that to change the dimension of your truss. So I like to always use equation or like a variables into equation. So now on the left, you should see below equation length 10 and 3. Okay. Now we can go back on the sketch. So double click on the sketch, double click or click right and click edit sketch. So I am on the sketch, and for this dimension, double click on it. You will type equal. You will have the global variable coming and length. Okay. You can delete those two. Oops. Delete. Oh my God, what's happening? Up. Okay. Oh yeah, because my 10 is very, very big. That's okay. Oops. Let's move this one. I will just delete this one. Click. Delete. I want to have this point the center of the bottom. So I click on the center and on the bottom, and I click midpoint. So now it's in the middle. And I want to have my 8. Sorry, that's a bit strange, but this between this one and this one, I want to be the 8, the equation. So equal, global variables, and 8. Here we go. And now the last steps is to have these points in the middle. So I want to move it. Let me get out of the smart dimension. So escape, escape. And I want to move this point. Yeah, why I can't move it up? Oops, let me see. I want to slide it up. Okay. So I will just create a construction line. So for construction between this point and this center. And I want it escape. I don't want it have a dimension. I want it to be vertical. Vertical. Here we go. That looks better, right? So I have my 10, my dimension 3, and my triangle. And this construction line just show you, just make this point in the middle because this construction line is vertical just above the center. Okay. And I will add a few more truss inside member. I will add one using the midpoint there. So try to snap this midpoint up to there. One from there to this midpoint, where this midpoint there. escape, and one more that will make that will put vertical. Okay, you can remove all those dimensions. I don't know what is, oops, escape. I'll put this dimension there, but you don't need them to have something fully constrained because this one is with the middle, this one is with the middle. So make sure that if you click on this line, you should see the middle sign there. Parallel, we don't need the parallel one. So remove the parallel one, and this one, just the middle point. Here we go. So you can click on all of them. This one are just coincidence there and there, vertical. Here we go. And what you, oops, let me see if I get out, if I must get, yes, get back, normal. And you see if you change the 8, so you double click on the 8, click right, manage equations, and you change it for 4, update. That will update the shape of your truss. I will just keep it at 4, at 10 and 3. Okay, make sure that you save. I will go grab a material. Doesn't matter. I think I made the example with cast alloy steel. So click right and select cast alloy steel. If you don't see it, click right and click edit material, and you can grab it under steel. So you have it like this. You click on steel and you will find the alloy steel, and you click apply. Oops, but it's already there. You need to select your sketch first. So you did the first part. Now, second part, let's apply some weld elements. So weld elements, my tab is there. Okay, if you don't have it, click right, click on toolbars, and select the weld elements there. Okay, if you don't have it, maybe try it in the customize. If you still don't have it, yep, you see, okay. And if you still don't have it, reach out to me. So weld element, we want to click structural member, and we want to apply the first one. We make it simple, and the group, we want to select the different parts. So group 1, 1, 2. You see, we can see the segment. Oops. I can select those 3 outside. Okay. I think you cannot select some that cut, but those 3, let's make group 1, and you click enter. And you click enter on the structural element, and now you can probably select the 3 inside. Yes, we can do that. Yes. Did I select the 3 inside? No, we cannot do this one. So oops, enter. And let's do one more groups, and let's do this one alone. Enter. And that depends of the one that you use, but you should have all of them as pipe now. Okay. And now we need to do the analysis. Did I lost my, no, simulation there. Here we go. So click right if you don't have it. Look at tabs, toolbar, customize, look at everything there, and you should find it. So new study, we want to do a static study. So your new study is static. Oops, you're good, and enter. And it will begin a new study. If you open the Truss, like check there that you have all your pipes, and click right and apply materials. The same one, apply, close. Okay, and you should see it later. I think you can just click cut list, apply, edit materials, and cast all, and apply and close. I think if we open it, yes, now if we open all the pipes, we shall see the material everywhere. So you can do it one by one, all of them. And so you can see the different pipe, number 1, number 3, number 2, number 1, number 2, number 3, okay, in the different groups. But you need to have to make sure that you have all of them. Okay, so now joint group. So up, double click, oops, click right, no, double click. Here we go, double click on them. So it will automatically find the joint, and you just need to select OK. But make sure that you have 1, 2, 3, 4, 5, the 6 joints. Enter. Joint are calculated. You're good. Connection. You don't have anything to do, but let's double click on it. We don't have to do anything with the connection. Fixture. So up, double click Fixture Advisor. And if you open on the right, you will see the Fixture Advisor. I know it's a little bit small. We will do add a fixture, and we want to use a reference geometry. We want to make some force reactions at this joint. And so this is the joint that we want, and this one, that's the reference. So you need to use the front plane. Okay, we will use the front plane for all our reference. It will just be the X and Y plane. So that's the easier things to follow. Now, oops, let me make sure that I talk about the same thing. So for this one, that's the one on the bottom left. So we will decide to just have the rotation on this one. So that's the pin connection. When it's gray, it means that there's no constraint at all. It's free to move. So we want them to not move. So we will open, click just there and leave the 0, 0, 0. So that means that there is no translation on X, Y, and Z. So there is a force Fx, Fy, and Fz. And for the rotation, we want to block the X, block the Y, but just leave the Z. So the pin connections allow the rotation there. So this one should stay gray, okay? And you click Enter. You click on the right, More Interaction, create more interaction, add a support fixture, add a new fixture, use reference geometry, select the joint on the right, bottom right. Reference geometry will be your front plane again. And this time we will leave the X translation free. So this one will stay gray. So that means that this joint can move right and left. It's kind of a roller. So we put this 0 for Y, 0 for X, for Z, 0 for X, and 0 for Y for the rotation, but it could still rotate on Z. Enter. And we want one more interactions, a support fixture. And now we need to add a fixture and use reference geometry. And the joint that you will use will be this one, this one, this one, and this one. Oops, which one was not selected? This one, this one, this one. Oops. Okay, this one. So you should have 4. Reference geometry is still your front plane, and that time we will want to leave free X and Y. The translation on X and Y, just block the Z and block the rotation on X and Y. So that should be gray, gray, white, 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 gray. Enter. Okay. We will apply some external load. So click on external load. There's 2 options. You can click external load advisor, or you can click on the right down, continue with the next advisor section. But we need to apply external load. Oops. External load, we want to add a load. So on the right, add a load. We want to apply load on joints. So you click joint on there, and you will select this one, and this one. Reference geometry will use the front plane again. So that means that we will use the same direction that the X, Y, and Z axis. And we want to apply some forces, 10,000 Newton on Z, and that should be on the direction going down. Let me check what we see. Oh, not on Z, sorry, on Y. On Y. And reverse directions. You can see the arrow there. It's very small, so it's hard to see. You can see it better if I scroll like this. Okay, everything that is gray doesn't apply anything, so just make sure that you just have the X, 10,000. And I think it's divided the 10,000 on the 3 load. Enter. Okay. Now let's see if the mesh work. So mesh advisor, no interference detected in your model. You're all good, and you can just try to run the study. Oops, it could take more time than it's taking with my computer. The deformation is about 0.007 meters, so 7 millimeters. That's good. That's small. The displacements, double click on it. You need to see the displacement. It should be symmetrical. This is much more like the scale. You see the scale is 137.6, so it's 100 times the displacement that will occur. And if you click on double stress, if you double click on stress, you see the stress. And what is super important is something that is perfectly symmetrical. Okay. I think you can. Okay, I will leave it the stress there. Don't touch that. But if you want to find out to get the axial loads, there's different options to do that. But my advice is to click on Report and just to publish. It takes a little bit of time. It generates a Word document. And I will show you what you need to check in your Word document. Almost there. Here we go. And now I will go grab my report. Oops, and I will move it there. So this is the report of the demo. Okay, so you have the date, the name of the study. And if you want, you can add some information there. You have the model, the name of the different pipe. And what is important is this column there, the beam forces. Okay. Oh, you see, so the interior model, the force are 30 kilonewton. So the 10,000 newton on each joints make it 30,000 newton. So it was not divided by 3, but just multiplied by 3. Okay. If you look at this column, axial load, the 19, 29, all of this, that should be the forces that you have inside each truss, the compression or the tension. So that's why you have twice the same. But for example, in the pipe number 3, so to know which one is the pipe number 3, you need to come back on your geometry there. Pipe number 3, 1, 2, 3. That's the one on the top right there. So the force in the pipe number 3 will be, pipe number 3 will be, that was this one, 29 kilonewton. So you can check that you have the same value when you do the end calculation. But all the value that you are looking for are in that column axial. Shear, that's your shear force. That's what we are doing in internal loads. And moment, same thing. And torque, not sure. And the beam stresses, so already inside the beam. This one is what you will learn in mechanics of materials, but you have all the data there. Just something to note, the value are not exactly the same that when you do the end calculation, because it's just finite element analysis and not just the exact number. And you have the value there. What I look when I open your report is that it's symmetrical, that's you have the same color on each member if you apply a symmetrical load. If the load is not symmetrical, it will not be symmetrical, but in that case, it should be. So yeah, you have different value, and you can edit the document and add information to it. So I hope you find this helpful. Don't forget to save. Okay, and when you do save, you will also save your static study. You can open it again later. When you will open your part, you will still be able to get back to the static study. So that's it for this little demo. See you later. Bye-bye.